In this video, I'll be explaining to you how to balance redox equations. The first step in balancing a redox equation is to identify what is being oxidized and what is being reduced. Oxidation means losing electrons, and reduction means gaining electrons. The second step is to separate the reaction into two half reactions based on the oxidation and reduction reactions. The next three steps require you to balance the redox equation stoichiometrically. Then you have to balance the charges on both sides of the reactions. And lastly, you have to add the two equations to cancel the electron. Let's go through an example. You're asked to balance the following redox equation. Copper plus nitric acid makes copper 2 plus ion and nitric oxide. Here's a chart for determining oxidation numbers. The oxidation number for something in its elemental form is 0. For atomic ions, it's the charge on the atom. For group 1 elements, it is plus 1, and similarly for group 2 elements, it is plus 2. For hydrogen, it is plus 1 when bonded to a nonmetal and minus 1 when bonded to a metal. Oxygen is usually negative 2, unless it is in peroxide, in which it is negative 1. Fluorine is always negative 1. For neutral compounds, the sum of the oxidation numbers is 0, and for ionic compounds, the sum of the oxidation number is the charge. Okay, so the first step is to identify what is being oxidized and what is being reduced. Copper has an oxidation state of 0, as it is in its elemental form. We have to break down the oxidation numbers for nitric acid. Oxygen is negative 2, but we have 3 of them, so we multiply by 3 to get negative 6. Hydrogen in this case is plus 1. As the compound has a charge of 0, the sum of the oxidation numbers must also be 0. Therefore, nitrogen has to have an oxidation number of plus 5. Copper 2 plus has an oxidation number of plus 2. In nitric oxide, the O has an oxidation number of minus 2, and since the overall charge is 0, the nitrogen must have an oxidation number of plus 2. As you can see, the copper has lost 2 electrons, making it an oxidation reaction, and the nitric acid gained 2 electrons, making it a reduction equation. Now we have these two half reactions. Next, we look at the next 3 steps. Our first step is to balance the atoms other than O and H. The copper is balanced as there is 1 on both sides of the reaction. We don't have to balance the oxygen as there aren't any, and we don't have to balance the hydrogen as there aren't any as well. Next, we add electrons to balance out the charges. The right side has a charge of plus 2, and the left side has a charge of 0. So to balance out the charges, the right side must gain a charge of negative 2. So we add 2 electrons on the right side. We're not done with the oxidation part of the reaction. For the reduction part, this part is a bit tricky. We first balance the atoms other than O and H. There is 1 nitrogen on both sides, so it's already balanced. Next, we balance the oxygen with H2O. There are 3 oxygen atoms on the left side and 1 on the right, so we have to add 2 oxygen to the right so that each side will have 3 oxygen atoms. We balance the oxygen with H2O, so therefore we add 2 H2O. Next, we balance all the hydrogens. There is 1 on the left and 2 times 2, 4 hydrogens on the right. So we must add 4 minus 1, 3 hydrogens on the left side. Lastly, we add the electrons to balance out the charges. Everything has a charge of 0, except for hydrogen, which has a charge of plus 1. And since we have 3 of it, we times 3, so it has an overall charge of 3. We must add 3 electrons to balance out the positive 3 charge. Now we have both equations, and we must make the number of electrons in both reactions on the opposite sides equal to each other. We multiply the first equation by 3, and we multiply the second equation by 2, so that we have 6 electrons on both sides. Now we add the 2 reactions, and notice how the 6 electrons get cancelled by each other. So we have this as our final balanced redox equation. Let's do one more example. You are told to balance zinc and nitrate with zinc 2 plus and nitrogen dioxide. The first step is to determine the oxidation numbers. Zinc has an oxidation number of 0. O has an oxidation number of negative 2, and we have 3 of them, so we multiply by 3 to get negative 6. The overall charge of the compound is negative 1. So negative 6 minus negative 1 gives us 5. So nitrogen must have an oxidation number of 5. Zinc 2 plus has an oxidation number of plus 2. The oxygen in nitrogen dioxide has an oxidation number of negative 2 times negative 2, which is 4. As the overall charge is 0, the nitrogen must be 4 to balance out the negative 4 charge. As you can see, the zinc lost 2 electrons, so it is in an oxidation reaction, making the nitrate the reduction equation. For the oxidation reaction, we must skip steps 3 to 5, as the zincs are already balanced on both sides, and there are no oxygen or hydrogens on either side. Step 6 requires us to balance the charges with electrons. The right side has a charge of positive 2 and the left side has a charge of 0. We have to add 2 electrons on the right side to balance out the charges. For the reduction reaction, we have to perform each step very carefully. Step 3 is done as the nitrogens are already balanced. There are 3 oxygens on the left side and 2 oxygens on the right side, so we add 1 H2O on the right side to balance out the oxygens. Next, we balance out the hydrogens. There are 2 hydrogens on the right side, so we must add 2 hydrogens on the left side. Lastly, we have to add electrons to balance out the charges. Nitrate has a charge of -1, and the 2 H pluses, also known as protons, have a charge of 2. The right side has an overall charge of 0. The left side has an overall charge of -1 plus 2, which is 1, so we must add an electron on the left side to cancel it out. Now we have 2 reactions. We multiply the second reaction by 2, so that I cancel with the 2 electrons in the first equation, and we get this. But since the question asks for it in basic solution, we have to do one more step. For each H+, we have to add an hydroxide ion on both sides, so we add 4 OH on both sides. Next, we combine the hydrogen and hydroxide to form water, and you should get this. Lastly, we combine the H2O on both sides and arrive at our final answer. And that is it for this video. Thanks for watching.